Ever wondered why some AI models seem stuck in their own thinking patterns, even when they're supposed to be learning and improving? Today, we're diving into a groundbreaking study that reveals a hidden constraint in one of the most promising AI techniques: reinforcement learning with verifiable rewards, or RLVR. Spoiler alert, it's like a dog on an invisible leash, and the leash is the model's own past. Let's start with the basics. RLVR is a method that helps AI models solve complex problems, like math puzzles or logical reasoning. The idea is simple. The model generates answers, and a reward system tells it whether those answers are correct. Over time, the model learns to focus on the answers that score high on this reward. Sounds great, right? But here's the twist. This study shows RLVR might not be as open-minded as we think. Imagine your AI model is like a chef trying new recipes. RLVR is like giving the chef a recipe book filled with dishes they've already made. The chef might tweak the spices to make the dish taste better, but they'll never try a completely new cuisine, like sushi, if the recipe book doesn't have it. That's the core of the problem. RLVR can't explore solutions the original model, the chef, never considered. Why? Because RLVR relies on the base model's existing knowledge. If the base model has zero chance of generating a certain answer, RLVR can't discover it, no matter how much it's trained. This is called support preservation. The model stays within the boundaries of what it already knows. The study even shows that, in some cases, RLVR actually shrinks the range of possible answers, making the model less diverse over time. But here's the catch. While RLVR makes the model more precise, like a chef perfecting a familiar dish, it might miss out on creative, underrepresented solutions. Think of it like a music playlist. RLVR could make your favorite songs sound better, but it'll never introduce you to a new genre if the algorithm never samples it. The researchers measured this with two types of entropy, a fancy word for uncertainty. Surprisingly, RLVR sometimes increases uncertainty at each step of the reasoning process, but in the end, it narrows down to the same few answers. So what's the takeaway? RLVR is powerful, but it's not a magic wand. It's great at refining existing knowledge, but it might not help AI break free from its comfort zone. The study suggests that future AI systems might need new tricks, like explicitly encouraging exploration or mixing RLVR with other methods, to truly expand their reasoning horizons. But here's where things get interesting. The research also introduces a solution: verifiable rewards, clear, objective feedback that tells the AI, yes, this is correct, or no, that's off track. Think of it like having a teacher who checks your homework instead of just saying, good job. This approach focuses on high-entropy minority tokens, those rare, tricky answers AI often misses. By prioritizing these, researchers found the model could tackle harder problems more effectively. It's like giving the AI a map to the hidden solutions, instead of just the main road. Mathematically, this works by anchoring the model's probability space to its original knowledge. If the base model can't solve a problem, the AI won't suddenly figure it out through reinforcement learning. It's a safety net that keeps the model honest. Meanwhile, the policy update, the algorithm that adjusts answers based on feedback, balances exploration, trying new things, and exploitation, relying on what works. It's like a tightrope walker using a pole to stay balanced. Too much focus on old methods and you stagnate. Too much experimentation and you fall. The implications are huge. This isn't just about making AI smarter, it's about making it more reliable. By focusing on rare but critical answers and preserving foundational knowledge, we're building models that can handle real-world complexity. Whether it's solving a tricky math problem or diagnosing a scientific mystery, the future of AI reasoning is looking pretty bright. So next time you see an AI tackling a tough problem, remember, it's not just luck. It's a blend of smart training, careful feedback, and a little bit of mathematical magic. Thanks for watching, stay curious, and we'll see you in the next video. Thanks for watching. If you like this deep dive, hit subscribe for more explorations into the world of AI. Let me know in the comments, do you think AI should prioritize precision or creativity? Let's discuss.